1.4. So in 1.3, we talked about simple random sampling. In 1.4, we're going to talk about other kind of more complicated or more in-depth ways of choosing a good sample. On your notes, you have a visual guide to kind of set up visually what the differences are between the four main types. The first one being simple random sample, which we talked about, and then the next three being stratified, systematic, and cluster sampling. Those are three good methods that we are going to talk about in this section. And then we'll talk about one poor technique that is often used to get a sample, but it's not a very good sample. So the first new type of sampling we're going to talk about is called systematic sampling. The most common use of systematic sampling is if you're doing quality control on an assembly line. Systematic sampling is where you take every nth item. So let's say you're at a factory that makes calculators. Your job as quality control is you take every 100th calculator off of the assembly line, you put batteries in it, you turn it on, and you make sure it works. It works, awesome, you put it away, and then you wait for the next 100th calculator to pass you, and then you grab that calculator and you do the same thing. This is the only type of sampling technique that does not require a frame. You don't need to know how many things are in the population. It is an ongoing process. So you can do this. I'm going to check every 100th calculator forever. And so you don't need a frame. It works very well for that type of work. So here you do quality control on an assembly line. But you can use it in other ways. The best thing about it is that you don't need to know the frame because you're just constantly looking at the 5th person or the 10th person or the 100,000th person or thing that you're making. All right, the next two, cluster and stratified sampling, often get confused with each other because at kind of like that top level, they look very similar. But once you dig a little bit deeper, there's a key distinction between the two things. So let's start with cluster sampling. In cluster sampling, the first thing you have to do is you break your population up into clusters. For examples, I like using Arapahoe High School. So we're going to use Arapahoe High School as our population. If we're going to break Arapahoe High School up into clusters, I could say each room is a different cluster. So I don't necessarily care about who's in the room. I'm using the rooms themselves as kind of the way I divide up my population. Once I've divided up my population into those clusters, I then use simple random sampling. Again, like I mentioned in 1.3, that simple random sampling is going to be kind of the backbone of a lot of these other techniques. So after we've broken up a group into our clusters, we then use simple random sampling to select entire clusters at a time. So if we were doing Arapahoe High School, we break it up into classrooms. I may randomly select 5 classrooms for my sample, which means all of the students that are in those 5 classrooms, that's what makes up my sample. So let's say there's an average of 30 students in a room at a time. If I grab 5 classrooms, that means I've grabbed 150 students to put into my sample. And that's the idea of cluster sampling. Next is called stratified sampling. Stratified sampling, the first step is you break your population up into things called strata. And so that's why it can be confused with cluster sampling, because the first step is, on the face of it, the same thing. You're breaking up your population. However, the difference between a strata and a cluster is very big. There's a big difference between those. Where I said classrooms were going to be my clusters, if I was going to do stratified sampling at Arapahoe, I could pick grade level. So I could say 9th grade is one strata, 10th grade is a strata, 12th grade is a strata, or freshmen, sophomores, juniors, seniors. So I've broken up my population into much larger groups than with clusters. These strata are much larger. They contain a lot more people. And then from within each strata, I randomly select individuals. The reason that stratified sampling is commonly used and really powerful is it allows you to really accurately represent your population in your sample. So let's say that Arapahoe High School has 500 students in each class. So 500 freshmen, 500 sophomores, 500 juniors, 500 seniors. If I want a representative sample of Arapahoe High School, I'm going to get a sample size of 100 students, and I want that to accurately reflect Arapahoe High School. If I did stratified sampling, after I've created my strata, I could make sure that I randomly select 25 freshmen, 25 sophomores, 25 juniors, 25 seniors, so that the percentage of strata is the same in the population and the sample. I make sure that those percentages are the same, so one group isn't overrepresented. Depending on how large your population is and how large your sample size is going to be, it also allows you to do something called multi-stage sampling, which is essentially having several different strata you're breaking up. So maybe instead of just grade level, I also want to do gender. So I break up Arapahoe High School into freshman, sophomore, junior, senior, but then within that, I break freshmen up into freshman boys, freshman girls, senior boys, senior girls, that type of thing. And that way, the more you kind of introduce more strata, the more accurate you can create a sample that reflects your population. And so that's why stratified sampling is commonly used in a very powerful technique. It allows you to get really close to making your sample look exactly like a smaller version of your population. So we go in here and it talks about our strata. It talks about some of the advantages of that. And then it talks about the difference between stratified and cluster sampling. And again, it's tricky because the 30,000 foot view of them is, hey, I break my population into different groups and then I grab things from those groups. The biggest difference is in a cluster, you grab clusters as a whole. You don't go inside the cluster to see who's on the inside. You just say, oh, that's a group of people. I'm going to take that whole group of people. Thank you very much. Whereas in stratified, you break the population into groups, but then you go into the individual groups to pick individuals at random. So you use those strata to determine how many people you're going to pick from each strata, as opposed to cluster where you just take the whole group. All right. The next type of sampling we're going to talk about is a pore sampling technique. It is probably the most common sampling technique, and it can be used effectively. It's just not scientific, and that is called convenience sample. A convenience sample is when you allow people to self-select into your survey. So self-select means maybe it's on ESPN, but you're watching ESPN and they put up a poll, who's going to win Monday Night Football this week, the Denver Broncos or the Pittsburgh Steelers? Go to our webpage and vote now. That's a convenience sample. And it provides information, it's fun, it can spark debate, but it is not scientifically relevant. It's not good research. And the reason is because you're allowing people to choose whether or not they want to vote, which means you're getting a biased sample. The people that are going to take the time to vote are going to be the people who are invested in that type of question. If it's who's going to win a Monday Night Football game against or from the Broncos and the Steelers, you're going to have more people that are either a fan of the Broncos or a fan of the Steelers voting for their favorite team. If you're not a football fan or you don't like the Broncos or the Steelers, you're not incentivized to vote. So you're getting skewed data because you're missing out on a large chunk of the population. Another place you might see this is people standing outside of grocery stores asking you to fill out a survey, or, hey, will you sign this? Those types of things. Anytime you get to choose whether or not you want to be in the survey, that is a convenient sample, and that data is generally going to be biased by the fact that people who choose to do it are typically incentivized by their feelings, and that's why they're opting to fill out the survey or answer certain questions. So convenient samples, they're fun, they're quick, they're easy. However, they're not scientifically relevant. So you will not see research papers that were based off of these kind of open choice questions where people got to choose whether they wanted to answer it or not. Next, multi-stage sampling. That's what I talked about, where you have multiple layers of strata or cluster sampling and stratified sampling. Kind of more layers you have, that is that multi-stage sampling. And we have three different types of sampling, or sorry, three different types of common surveys. You have a personal interview, you have a telephone survey, you have a mailed questionnaire, and more of these, instead of mailed questionnaires, they're going to be emailed, or they're going to be at the end of a website. So let's say you go on to order a product, or you go to your bank website and you do something, and at the end they say, hey, would you mind taking a short survey about your experience? That is that kind of mailed questionnaire, but nowadays, generally it's emailed. Quite often they're online. All right, and then in summary, we have the three good techniques for sampling, and we have stratified, cluster, and systematic. And again, systematic and cluster have that simple random, or stratified and cluster have simple random sampling kind of as a backbone of their sampling techniques.